Hey guys, so today we're going to talk about pages 634 and 635. So before we get going, make sure you have all of your highlighters and your pencil ready. Please, please, please do not tear your pages out. Say it with me. Do not tear the pages out. Okay, remember, keep them in your book because I want you to make sure that they're all in one spot. Okie dokie, let's go ahead and get started. So I'm at the top of page 634, putting it all together. So there are more than 100 elements, but you can see that there are many more types of matter than that. Well, what are these other types? Okay, so we're going to kind of get into it. So with your pencil, underline active reading. As you read this page, draw boxes around the names of the two things that are being compared. Okay, so I'm going to start reading the paragraph, so I need you to stay with me. Okie dokie. Many atoms go through chemical change with a different type of atom and form molecules. A molecule is made up of two or more atoms joined together chemically. A compound is a substance formed by atoms from two or more elements. Okay. The properties of a compound are different from the properties of the elements that form it. For example, atoms of carbon and oxygen will react. Now, forming the compound, but they form the compound carbon dioxide. This compound has its own properties that are different than those of carbon and oxygen. Okie dokie. With your orange highlighter, I need you to highlight the definition of molecule and compound. In blue highlighter, I need you to highlight the properties of a compound are different and the word compound a few lines underneath it. Now in pink highlighter, I need you to highlight atoms of carbon and oxygen will react, forming the compound carbon dioxide. Okay, now before we kind of discuss a little bit about that, I want to read the bubble up top at the top of the page. So, part of my atomic theory stated that different types of atoms combine to form chemical compounds. Okay, hold up. Now in green highlighter, you need to highlight atomic theory stated that different types of atoms combine to form chemical compounds. Now, we all know what chemical means, and we all know now what compound means. So a chemical compound is the chemically joining of the atoms. Okie dokie. Let's talk about the bottom of this page. Well, before we talk about even the bottom of the page, what's our active reading? Who knows? Okay, well, if you said from, oh no. If you said from two or more elements, you would be correct. That's one of them. What's the second thing we need to box? Okay, now it is also highlighted. If you said the properties of the compound are often different, you would be right. So we're comparing from two or more elements as well as the properties of a compound are different. Okay, let's go ahead and move on to the bottom of the page. So this is an example of the different types of atoms forming certain things. Okie dokie. So these would be considered compounds. Okie dokie. So we're looking at our hydrogen atoms, which are right here. Oops. Didn't mean to draw on it. So we have hydrogen atoms. We have one oxygen atom, which equals water. So this means for every one oxygen atom, there are two hydrogen atoms attached to it. Okay? Now let's look at the sodium atoms versus the chlorine atoms. So we have sodium atoms, chlorine atoms, but let's count. Let's physically count all of the sodium and chlorine atoms. Okie dokie. So I'm going to zoom in just a little bit. Now let's count. Ready? We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That's pretty good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 9 chlorine atoms too. So that means for every sodium atom, there is 1 chlorine atom. Now when I add all of these things together, they all combine into one thing, which creates salt, which we just did last week. How we dissolved salt into water. So sorry. Okay, let's move on. So I'm at the top of page 635 now. Okie dokie. So compounds are made of atoms of at least 2 different elements. Now, an element, remember, would be calcium and chlorine, sodium, nitrogen, oxygen, lithium, carbon, oxygen. All of those things that I just listed are all different elements. Okay. Now I'm going to read what's in the purple little box. Some of the colors in the fireworks come from compounds. So sorry. For example, calcium chloride. Yes, calcium chloride, which contains 1 calcium atom for every 2 chlorine atoms, results in an orange color. Exactly right here. So for every one calcium atom, there are 2 chlorine atoms. So that means that those 2 chlorine are attached to that 1 calcium, and for it to make more orange or brighter orange, you just add more calcium and more chlorine. Okie dokie. Let's look at yellow. What different elements make up the yellow color in fireworks? Now, we all love to watch fireworks on the 4th of July. That's what I just think of as 4th of July when we see fireworks. Anywho, let's look at what makes up that yellow color. So, we say it, sodium nitrate. Okay, so let's look at how many there are. So, we have 1 sodium, 1 nitrogen, and 3 oxygen. Okay, let's go back here. So for every sodium and nitrogen atom, there are 3 oxygen atoms. Okay, that's pretty neat. Now let's look at the color red. Who loves red just like I do? Oh my gosh, it's my favorite color ever. Okay, let's look at the color red. So how do we say this? How do we say the name of this? Yeah, if you said lithium carbonate, you are exactly correct. So lithium carbonate. So let's look at all these different elements that are in the color red for fireworks. So we have 2 lithium, 1 carbon, and 3 oxygen. Yeah, you heard me right. 2 lithium, 1 carbon, and 3 oxygen. So let's look at it super duper quick. Okay, I'm going to erase all of my ink, and I'm going to zoom in. Okay, so let's look. So here are my 2 lithium. Right here is my 1 carbon, so that means that these 3 over here are my oxygen. So let's break it down. For every carbon, there must be 3 oxygen atoms and 2 lithium atoms for the color red to be present in fireworks. That's neat. Oh my gosh. Okay, I'm going to erase my ink really quick. Okie dokie. That was fun to find out, wasn't it? Yeah. Fun fact of the day. If you want to impress your parents, you just tell them, I know what elements make up the colors in fireworks. Okay, just a fun fact. Okie dokie. Let's go ahead and just move right on. That was fun. Okay, so I'm at the bottom of page 635. Fructose. Fructose? Yeah, you heard me right. Fructose. Fructose is often called fruit sugar. For every 6 atoms of carbon in the compound, there are 12 hydrogen atoms and 6 oxygen atoms. That is a lot. So with your yellow highlighter, I need you to highlight the word fructose and fruit sugar. Okie dokie. So we are going to be doing the math today. People, we know how to do this. I promise. So I'm going to do number 1 with you, and then you are going to do 2 and 3 by yourself. Okay. So let's look. With your pencil, I need you to underline 6 atoms of carbon, 12 hydrogen atoms, and 6 oxygen atoms. So let's add all of those together. So under do the math in green highlighter, you need to highlight. Add the total number of atoms in fructose. So let's do just that. Okie dokie. So we have 6, 6, and 12. Well, what's 6 plus 6? 12. We know that. Didn't have to tell us. Well, if 6 plus 6 is 12, okay, I have 12 and 12. What's 12 plus 12? Yeah, 24. You're exactly right. Okie dokie. So that is my denominator. Okay? That's my first denominator for number 1. So I'm going to write, So I'm going to write 24. You know what? Let me do it in a different color. That way you can see it better. 24 is my denominator. Okay? Now, I'm looking for the fraction of carbon atoms. So how many carbon atoms are there in fructose? Well, let's go back over here and look on the left. There's 6 atoms of carbon, 12 hydrogen, 6 oxygen. Wait, carbon, 6. Okay, so I'm going to put 6 on top of 24. Now, in pink highlighter, you need to highlight, in lowest terms, what fraction of fructose consists of. People, this is reducing the fraction. Dun, dun, dun. Reduce the fractions. Okay, so let's just reduce really quick. 6 can go into 6. So is 6 the highest number that can go into 24? Sounds right. So what is 24 divided by 6? 4. Yeah, so that is my denominator. And what is my new numerator? If 6 divided by 6 is what? 1. Yeah, you're exactly right. So there is your answer for number 1. Okie dokie. Now it's your turn to do number 2 and number 3. Set it up exactly like I did. So your denominator for each one to start off with is 24. Okay? Then you will reduce it to the lowest possible fraction. Okie dokie. Awesome. And last but not least, one last thing. Private message me the answer. What elements make up the orange firework color? If you get it correctly, you will get 1 bonus point on your homework. Okie dokie. Let me know if you have any more questions. I will see y'all later.